2171 class, this is a homework example. This is from section 1.8, and this is problem number 2. So what we're supposed to do here is to determine if these two functions, f and g, are inverses of each other. Okay, and you remember what we have to do here is we have to put g into f and get out x, and turn around and put f into g and get out x. And if both of those things happen, remember and means both have to occur, then we have an inverse. If only one occurs, the other doesn't, or neither, if at any time you don't get x, then you don't have an inverse. Okay, so the first thing we're going to do is put g into f. So all of this right here is going to replace this x. Okay, everything else stays the same, 6 times. Alright, so this is f of g. So 6 is being multiplied by the input. Well, the input is now g of x. So this whole entire function is the input. So x plus 6 over 8. Alright, and then we subtract 8. So minus 8. Alright, now when I multiply here, notice the 6 and the 8 can reduce. They're both even, so I can reduce that to 3 and 4. Okay, so I end up with 3 times x plus 6 over 4 minus 8. 3 times x is 3x. 3 times 6 is 18 over 4. And then to be able to combine this 8 with it, I need a common denominator of 4. So 3x plus 18 over 4. If I get a common denominator of 4 down here, I would need to multiply this by 4 also. So that'll be a 32 on the top over a 4. Alright, and then positive 18 minus 32 is negative 14. So we end up with 3x minus 14 over 4. Okay, and that's not equal to x. So these are not inverses of each other. Okay. Alright, but I still have to find g of f of x. Alright, so for g of f of x, I had to put the f function into the g function where the x is. So 6x minus 8 is replacing the x. Okay, that's where the x was. And then plus 6 divided by 8. So minus 8 plus 6, that's a minus 2. There's a common factor of 2 here, so I'll pull the 2 out. 6 divided by 2 is 3x minus 1, or sorry, minus 2 divided by 2 is minus 1. And then this 2 and this 8 will reduce, and I end up with 3x minus 1 over 4. Again, that's not equal to x. Neither of these are equal to x. So these are not inverses of one another. Okay. Now, if you're just determining if two things are inverses, then you could really have stopped right here. They're not inverses. But on your homework, what you're going to see is that you're not asked if they're inverses of one another until part C. So you still have to find, even though this is an x, and so I know they're not inverses as soon as I'm done with part A, I still have to go in and find g of f of x because that's part B. So you'll still have to do both, even though we really know that we're not dealing with inverses as soon as we're done with the f of g of x, which is part A in this problem. Alright, and then this is question number 15 from the homework. So we're given this function, the square root of x minus 9, and we're supposed to graph both of these in the same rectangular coordinate system for part B. So I'm going to go ahead and graph this. Now if you remember, from 1.6, just shifting these base functions around, the square root of x starts at the origin and kind of looks like this. Okay, so we're going to move that around, but in particular the points I'm going to move are 0, 0, 1, 1. Alright, the square root of 0 is 0, the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Right? And all these points are going to be moved to the right 9 places. Right? So the origin 0, 0, when I move it, I'm going to move it, the new function to be blue. When I move it, I'm going to get, instead of 0, 0, I'm moving 9 to the right, so that's going to be 9, 0. Right? Instead of 1, 1, that's going to be 10, 1. Right? Instead of 4, 2, that's going to be, add 9, that's 13, 2. Right? And then instead of 9, 3, I'm going to get 18, 3. Alright, so there's where that new function is going to go. It's going to have that kind of look to it. So there are the 4 points that I plotted to shift this thing off from the origin. So now I'm going to erase those original 4 points because I just shifted. I just plotted them in there to shift them. But remember, when you do F inverse, those points are going to be reversed. So I'm going to have 0, 9, 1, 10, 2, 13, and 3, 18 are going to be plotted on the inverse. So 0, 9 would be right here. Alright, and then 1, 10, I go to the right one and up one more, 10. Alright, 2, 13, there's 10, 11, 12, 13, and 3, 18. So there's 13, 14, 15, 16, 17, 18, there's 3. Alright, so there's what this thing would look like. So this is actually, I'm doing part B right now actually by plotting these points flipped around the other way. And remember that the line y equals x, which starts at the origin and goes diagonally up through the first axis, or the first quadrant there, that's the line of symmetry here, and it looks like we have that line of symmetry. Alright, but let's do the actual math here. To find f of x, remember, we replace f of x with y, and then we flip-flop x and y. So these two change places, so this is x equals the square root of y minus 9. Alright, I need to square both sides to get rid of that radical, so that's an x squared equals y minus 9, and then add 9 to both sides. So I end up with x squared equals, x squared plus 9 equals y. And then remember we replace y with that f inverse notation. So f inverse of x equals x squared plus 9. Alright, then it wants us to use interval notation to get the domain and range of both of these. Well, notice the original function, because it is a square root, we have to have 0 or positives underneath here. So we needed, for the original function, which I got in blue, our domain was 9 to infinity. Okay, we had to have a 0 is the smallest number we could have under here, and that takes place at 9. And then anything bigger than 0 is fine. So 9 to infinity. Alright, that's the domain. And then the range of this thing, if you look at the picture, when I plug in 0, I get out 0. And then I plug in anything positive or bigger than 9. I'm sorry, when I plug in 9, I get 0. And when I plug in anything bigger than 9, I get positive. So the range is 0 to infinity. And if you remember, for f inverse, it flips around. The domain of the inverse function is the range of the original. So 0 to infinity, and the range is 9 to infinity for this thing right here. And if you look at it, x squared plus 9, when I plug in 0, I get out 9. If I plug in anything bigger than 0, which is what the domain says, if I square something bigger than 0, I get a positive value, and if I add 9 to it, then I'm bigger than 9. So end up with something bigger than 9 for the range. Alright, so that's what part C is asking us to do. Alright, so don't forget you can also use your calculator to help with this. Just know that you're only graphing basically the right side of this x squared plus 9, because this is a function and it is 1-to-1 that passes the horizontal line test, so it does have an inverse. And if you drew the left hand side of this graph, then that's no longer a function with an inverse. So you got to make sure that you only graph the right side of it. Alright, and then just know when you plug these in and do this problem in your homework, you do have to put that x is greater than 0 from the beginning. Right, that x is greater than 0 comes from the fact that in the original function y is greater than 0. Okay, so remember domain and range flip-flop. Right, and then this is the only one that looks like what we've got here. Okay, and then there's the answer to part C, that interval notation that we've talked about there. Make sure that you use brackets, okay, because it's fine to take the square root of 0.